Hello YouTube, this will be part 13 mini lathe rebuild. I got the power supply for the brushless motor. Picked this up on Amazon. As you can see, let's see here, this is a 1N10 or 220 volt in, and it is output is 24 volts at 20 amps. Okay, so I'm going to set up temporary wiring. I'll probably have a remote switch on it when it's done, but just for testing the motor today, I'm going to go ahead and wire it up pretty decently so I don't cross any wires or burn anything up. And I got some parts here, I got my tools, and so we're going to start. Switch. I was looking for a bracket or something to put a switch on, and I just said, well, you know what, I'm just going to go ahead and drill in this aluminum here. So I'll start by drilling the hole. Alright. I have my calipers here. I'm just going to check and see how wide this is. 2260, 2260, 15/64. See here. Alright, that'll work. I have a little cheat sheet up here with decimal. Fractional decimal conversion chart really helps. Alright, and then we're going to get aluminum chips all over the board, and then we can make some smoke, right? Alright, I'll turn this thing upside down. Oh, when I received this, if you can see this corner here, it's all bent up. Now, I did not drop it. This is exactly how it came when I got it. It was wrapped in plastic, but it had been previously dropped. I was going to go that way, but I can't get straight up and down, so I'll go ahead and definitely go the other way so I can get aluminum chips all the way over the motherboard, or the power board there. I noticed this drill's wobbling all over the place. These are Harbor Freight bits, and somebody told me to check them. They're all bent right when you get them, and they are. Brand new from Harbor Freight, and the bits are bent. Imagine that. Alright. Let me get all my aluminum chips out. I'm going to get a file on that. Hold on. Get the rough edges off. Now, I don't know. I was thinking about mounting this first prior to soldering, but then I could drop solder on the board. Well, I think I'll tell you what, I'll hold off on that, and I'll kind of tell you what I have for a design here. This is just a standard Euro plug, you know, like you use for a computer. These, you know, whenever I need a cord, these come in really handy. And I have bunches and bunches of these. So I cut off the Euro plug-in. This specific power supply has the inputs here. Load, neutral, ground, and then there's 3 commons for the 24 volt and three positive for the bus, and then there's a green LED here. The light is not that great, and a defined voltage adjustment, which we'll see with this thing. I haven't adjusted it, but we'll see what it's like, what the voltage is without adjustment, and then we can fine tune it. Alright, so the thought is, starting about here. going to bring this here. I think that'll be good. So what I want to do is very carefully take this razor here and split it. You don't have to necessarily go down to the wires inside. You can actually just go through most of the wire here. If you go through and you push real hard, what you'll end up doing is taking the shielding off of the internal wires, is what you don't want to do. And then these, I don't know if there's a standard here for which wire equals which. One's got like a fine white powder in here. So I'll just get the voltmeter and I will just go ahead and use the ohm meter and test out which one is which one. So I'll go ahead and strip the ends of these wires, and then I'll go ahead and ohm them out. Okay. And then, so I don't forget, I'll write it down. So make sure you can see the meter here. And probably most of you guys know how to do this, but for the people that don't, I'll just go ahead and show you. This is an open circuit, and this is actually designed to test resistance. And in this case, we're just checking for an open closed. So that's open, and then when I put these together, there is let's see here. I'm having problems here with this voltmeter. Okay, 0 resistance. Okay, and it's auto ranging too. But in this case, all I'm using it for is to identify like which is the ground. So I'll go ahead and put one lead on the ground, and I'll check these wires here. Okay, yellow is the ground. Okay. Then this is the hot lug here. If you look at a standard electrical outlet, you'll notice that one of the lugs is smaller than the other lug. I don't have one specifically handy, but it is this lug here, which this would be the one that's in line with your breaker. So I believe this is going to be the brown wire. Alright, maybe it's the blue. Or maybe again my meter just quit working again. Open. Okay. Brown. Blue. Okay, so the hot is blue. So I'll put B for the hot. And then by deduction, I can figure out the BL for blue, VR for brown, and we'll put that as the neutral. Okay. Okay. And so the thought here is that what we're going to do is we're going to switch the hot. The the blue wire. We're going to switch that. So the brown will go to the neutral lug. The yellow will go to the ground lug. And then the blue wire will go through the switch, and then it will go here to the load. And then when you turn the switch on, my guess is the LED will come on. I would imagine power in. So that's what I'll make right now. I've got these little nylon doohickeys, like cable straps, and for like a strain relief. I mean, this is open, it's not going to be boxed in, but you know, sometimes when you yank on a cord, whatever, pull wires out. What I'll go ahead and do is I'll go ahead and put these lugs here on the yellow. And these wires are not really big, so sometimes I just double them over like that. And then crimp them. Okay, and then the brown, which is the neutral. I'll go ahead and I'll crimp that. Lighting and webcam. I've been filming with my camera. I've got a Galaxy Edge Note. Videos are amazing. On this video, I decided to try to use this. It's a Microsoft USB cam. It's a Cinema. It's a 720p. My camera operator is busy right now and wasn't able, but I wanted to get this one out. They will be here later on. So, all right. One of the fun things about these lugs is unless you get the exact right size, sometimes they don't go in there. And so a little trick I do, let me just show you here. So we're going to go ahead and put the ground, which is the yellow wire, and we'll see that it won't go in there. So there's two things you can do. I think these are like a standard size. You can kind of squeeze it sometimes, but then you fold it. Or another thing you can actually do is just if you got some really sharp cutters, you can take these sides off just a little bit, and you know, it never focuses on what you want it to focus on, but as a comparison you can look. So just cut the edges off a little bit, and as you can see, then it will fit into the hole. Okay, I'm going to go ahead and trim this one up. I bought, these are, let's see here, these wire strippers, Gardner Bender GB. I don't know, I found a pair, and they're really amazing. These are great. I think they're stainless. The cutters are really sharp. They were not inexpensive, but the pair that I had somebody was stripping hot wires and had shorted a couple of these out, so I went and found another pair, and they're absolutely great. I love these wire strippers. Just want to show you that. Okay, so this will be our brown wire, which will be the neutral. Okay, and the blue wire, which will be our hot wire here. Okay, I have some heat shrink tubing here, a couple different colors. Yeah, that will fit. Okay, and let's see here. I guess we can go ahead and we'll fit this. Uh-oh, my dimensions are not exactly on here. Oh, yes they are. I just wanted to fit that in to kind of see which way I'm going to go here with this guy. Kind of thinking like that, but it won't work like that. I think that'll be fine. Again, this is just a temporary setup. Yeah, I think that's pretty good. This is a 6/32 nut and Allen screw here. Yep, that's going to fit through there. Okay. I'm just hunting around here for the right tool, but I'll just use these here because I can't find my Allen right this second. Okay. Now, this will just help you if you accidentally yank on it or something, keep from pulling the wires out, maybe shorten something out, but I don't think I'd swing this thing around by it by any means. Okay. So we'll pull this out for doing the actual soldering. One thing I love to forget is that I always forget to put the heat shrink on there before I solder. That's always fun. So for the video here, I will not forget it. Or I would have. Okay. Alright. Grab some other wire. Actually see if this will fit on here. It's a little bit bigger. Yes, it does. A little tight. It'll work fine. Okay, and just strip back a little bit here. Okay. It's obviously way more than we need. I don't know if I want to try to fit it through this. What we're going to use here is there's 3 lugs. This is a single pull, single throw switch. And it's got two positions, and then when it's in one position it will tie this connector with this connector, and then when it's in the other position it will tie this connector with this connector. So we're just going to use the center and either one of the outside ones, not both. Alright. So sometimes you can slide your wire through there. I know with the other wire it won't work because it's way too thick. Okay. Some more Harbor Freight tools. They're not the best, but boy, you can get a lot of them for a little bit of money. Alright. So some people would probably use a soldering iron. I just get tired of that. I like the soldering gun my better. This is like a Weller. You get big heat real fast with these. Soldering iron, you got a plan. Alright. Boy, I tell you what's nice to have a camera operator that can zoom in on things. Alright. Well, that's good, but my wire is going absolutely the wrong way. It's a good joint, but in this case, you might not even need this heat shrink. I figured I was going to try to do it right. Yeah, I just believe that heat shrink's too small. Alright, well, let's go ahead and try to get our second wire, and maybe it will go lower. I'm just going to tin this lead here. I don't know what you can see, how well you can see. Okay. Make sure you don't have your electrical cord plugged in at this time. Okay. Alright, we'll pull there. I don't know how well these are going to work on this one here. Now, I guess I would have needed to go with some larger diameter heat shrink here. Let's check this. I'm going to get one of these wires covered up anyways. I get metal chips coming off the lathe. My camera operator came back. I don't know why. Desperate need. I'm going to stick right there with that. Okay. Alright, just a couple more steps and we'll be able to test. Power supply. And then drop the, there it is. This little star locking washer. That little piece that I'm not going to be using is to, if you want to drill a secondary hole, it'll keep your switch from spinning. If I do leave this switch on here permanent, it'll kind of just be a backup off and on because I intend on putting a remote in. Good. Okay, then power will come into there, go to that center lug, and then it will go straight here to the load, designation of load. Alright, and just like we did the other ones, I'll trim these ears. Alright. Be off. Just hold on for a second. Just get a few wire ties here. Let me try to clean this up just a little bit. Alright. Alright, let's test. We'll test, see if the LED actually comes on. And then we'll test what the output voltage is and see if it needs any adjustment. Alright. So it should be 24 volts. I'll put this on the DC scale. This is a common ground. And let's get hot. Plus. Okay. DC scales on. Okay, you guys can see the voltmeter. So the switch is in the off position now. Okay, now we'll go ahead and flip to the on position. You guys are ready for some smoke? Here we go. Alright, the green light did come on. With no adjustments, it's showing 26.10 volts. And our application, we're calling for 24 volts. Which would be an equivalent of S6 lithium. Let me find my little screwdriver here. I'm sure you guys can't see this, but there's a little adjustable pot right here. Fine-tune your voltage. but no, well, this actually is a Craftsman, but I'm pretty sure it's still manufactured in China. Actually, I probably ought to use this as a base to set this instead of the opposite way around. But in this case, I got the pot right there in front of the AC, so I could cause a lot of sparks here. I don't know if I can get it at an angle here. I'm unable to turn it here. So in considering safety, I'll leave this alone. But you can see it's putting out 26.12 volts. I got a couple other voltmeters around here. I'll check those as well, and just see if I can put this down, see if it is actually 24 volts. So the next step, if you guys watched the previous videos with the brushless motor, is to take this power supply and hook it up to the electronic speed controller, and then do another test. I know this was a long video. Just wanted to show you as much as I can. Anyway, thanks for watching, YouTube, and then we will stay tuned for another episode. Thank you very much.